All right, so what we have here is a problem that is asking us to write the electron configuration for an atom. Ooh, this is weird. So what we're going to do is we're going to take the material that we've already learned about drawing sublevels in our sublevel notation, and we're going to combine that to make this. To do that, what we actually need to do is, if you need to pause the video here and write down that question, you're welcome to do so. We're going to come back to it, though. We are going to draw something else on here. We are going to draw, I'm going to zoom in a little bit, and I'm going to make mine right about here. Is a really good place to do this. We are going to make something called the diagonal rule. If you look up the diagonal rule, if you Google it and you find somebody else who does this, or if you use somebody else's, if you go ask one of the other chemistry teachers for help, for example, which I'm not against, they're going to draw theirs slightly different than mine. I happen to think that a lot of chemistry teachers make this more difficult than it needs to be. So if you see this elsewhere, you'll see it slightly different, but it still applies the same way. You always use the diagonal rule the same way. To make the diagonal rule, what we're going to do is we are going to write out our electron sublevels, and we're just going to write them out just like this. So remember, the first sublevel is in the first level, so that's 1. There we go. I'm getting to the point where I can write on this thing. All right, here we go. All right, so 1, and the first sublevel is the S sublevel, right? So 1s is what we've got. I'm going to make this look a little nicer. Let's see if we can make that actually look like a 1. So there's 1s. All right. To make the diagonal rule, what we're going to do is we're going to have a diagonal that's going to form all of these sublevels. It's going to look like it's kind of diagonal. So what I'm going to do is I'm going to move down, and I'm going to move over, and I'm going to start writing the second level on the second line here. So here on this line, we're going to write, well, what's the first sublevel is 2s, and then the next one is 2p. If you have a gridded paper, this one's not showing me the grid. It is supposed to be gridded, but it's not showing it. You can put these in grids, and it makes it look really nice and neat. All right, so there's the 2s and 2p. Remember, second level, only 2 sublevels, right? So we're going to come down, we're going to indent again, and we're going to have the 3s. We're going to have the 3p, and we're going to have the 3d. All right, come down, indent again. We're going to have 4s. We're going to have 4p. We're going to have 4d, and we're going to have 4f. And I'm going to tell you, always remember 4f. 4f is kind of a neat one, but f is going to be the last thing that we need. A lot of folks associate f with chemistry. I'm not sure why. Anyways. So next up is 5s, 5p, 5d, and 5f. So again, we're going to stop at f right there. Indent one more time. We're going to do 6s, 6p, and 6d. And we're actually not going to do 6f or 6g. We're just going to stop right here. And you'll see why, hopefully by the time you work this enough. Indent one more time. We got 7s. We got 7p. This is why I call it, I like the diagonal rule. I like this. It looks like a diagonal, right? It looks like we've got kind of a diagonal going here. Some of these probably could have been a little bit straighter, but you know what? That's cool. The other reason for the diagonal is what I'm about to show you right now. I'm going to do this one in blue ink. So what we're going to do is we are going to start up here. So you start up here. Start. There we go, with a T. And we're going to go down to the bottom of a column and then back up. And then we're going to go down a column and then back up to the top. And we're going to go down to the bottom, then back up to the top. And then we're going to go down a column, then back up to the top, and then down a column. And then these arrows are getting worse. Down, up, and then back down. See where the other name for the diagonal comes from? All these diagonal lines that I'm drawing, right? So there's our diagonal rule, okay? There's our diagonal rule. And you're going to start up at the top and go down, work your way back up, down. I'm like, what the fudge does that mean? What the heck am I doing? Well, that's what we're going to do here. I'm going to scroll out just a little bit. Oh, by the way, if you need to pause so you can finish drawing yours, go ahead and pause and do it. I actually am going to get rid of the arrows right now. because the part that I need to be able to read is this part right here. Okay, I need to be able to read that, so I'm going to make sure. Hopefully, if you drew yours a little cleaner. And if you're one of those people who waited and said, I'm going to wait until he finishes drawing it to draw it, here it is right here. All right, so we're going to scroll back out a little bit, and it says, what is the electron configuration for an atom with 23 electrons? So I'm going to zoom in just a little bit more. All right, I'm going to answer that question right up here, and I'm going to do that. Let's pick the green pen. Why not? Heck yeah. All right, so what we're going to do is we're going to have 23 electrons up here. All right, we are going to put those electrons into sublevels, filling them up, moving down the diagonal rule until we've used up all of our electrons. Okay, this principle is called the Aufbau principle, and it literally, for those of you who don't know any German, I mean, shame on you for not knowing any German, I tell you. Aufbau is German for building up. So we are literally going to build up an atom by putting in these 23 electrons. So where do we start? We start at 1s. All right. How many electrons can you put into 1s? Well, I can put 2 electrons, right? That's the maximum you can fit in s. So now that I've put 2 electrons in, I'm going to have 21 electrons left over, right? So now we're going to go to the next thing. So we go down this column, and we get to the end of the column, which is, there's really only one thing. Can one thing be a column? I guess. We go up to the top of the next column, and we go down that column. Well, what's the next thing we come to after 1s is 2s. How many electrons do I need to put into 2s? Well, I can put a maximum of 2. I have at least 2 to put in there, right? There's 21. So I'm going to put 2 electrons into 2s. Now I'm going to mark out 21. Take away those 2 electrons. I'm left with 19 electrons. All right, after 2s, where do we go? Well, that's the bottom of this column. We go up to the top of the next column. We start coming down, and we get to 2p. Sorry about that slash there. We get to 2p. The 2p, how many can we put in a p sublevel? Aha! There I have to remember. S can hold 2, but p can hold 6. So I'm going to put 6 electrons in 2p. All right, 19 minus 6 is 13. I've got 13 electrons. So after 2p, we keep going down until we get to the bottom. And we get the next thing after 2p is 3s. So here's 3s. Oh, doggone it. Let's just erase that all the way then. 3s. How many can I fit in s? I can fit 2. And so we're going to take 2 out of our 13. And we get 11. All right, after 3s, we wrap back up to the top, and we get to 3p. 3p is the next one. How many can I fit in 3p? I can fit 6. So we're going to take 6 out of our 11. We're going to put down 5. We got 5 electrons left. After 3p, where do we go? We do not go to 3d. You do not go to 3d. You go down the column. After 3p is 4s. Folks, this is a really weird part of nature here, that the next thing after 3p is 4s. It's not the next 3. How many can I put in 4s? I can put a maximum of 2. There were 5 left. Now there's only 3. What do we go after 4s? After 4s, we're at the bottom of this column. We go to the top of the next column, and we get to 3d. 3d. How many maximum can I fit in 3d? 10. Exactly. I can fit 10 maximum. Oh, but I don't have 10 to put in there, right? I'm only down to 3. So guess how many I'm going to put in 3d? I'm going to put 3. And just like that, we get, this is the Aufbau principle, the Aufbau process for drawing an electron configuration. Now I want you to try it, all right? You are going to try a couple of these. I want you to try, excuse me, I think it's going to stop me here, and I want you to try one with 15 electrons. 15 electrons. If you got that right, Oh, and by the way, before I pause here and make you enter one in, maybe I should teach you how to do this. The correct way to do this is don't put any spaces, and you just do 1s2, 2s2, right? Don't put any spaces in there. Just when you're writing it out like this, when you're putting it into the correct solution, just leave out. Don't worry about putting carets or anything like that, because remember, this is red. 1s2, 2s2, etc. So you don't have to worry about that. Now pause the video. All right, hopefully the correct answer that you got for that is 1s2, 2s2, 2p6, and there we have 10 electrons so far, so I only got 5 left. 3s2, 3 left, 3p3. Check. If you got that correct, fantastic. If you didn't get that correct, probably need to work on that some a little bit more. Try and go back and watch the video some more. And now I want you to try one. We're going to go higher than 23. We're going to go up to, ooh. I got to rearrange my hand here. Here we go. 33 electrons. Try it with 33 electrons. All right, you're back. So let's do 1s2, 2s2, 2p6, 3s2, 3p6, which gives me, now I'm up to, and by the way, some folks are going to learn the trick. You can keep count of how many electrons you got. That one's 2. 2 plus 2 is 4. 4 plus 6 is 10. 10 plus 2 is 12. 12 plus 6 is 18. If you want to keep checking, after 3p, we go to 4s2, which is 20 electrons. After 4s, we go to 3d, which is 10 electrons. And that's 30 electrons total. And now I only have 3 more electrons to get me to 33, right? So how much do I put in 4p? Oh, look at that. I picked 2 random problems. Both of them end in p3. Isn't that funny? But there you go.